Today, we're digging into a single number that is, kind of taken over scientific research. It's a number that shapes careers, directs funding, and pretty much defines what success even looks like. But what if that number and the whole system built around it is based on a huge mistake?
I mean, think about it. How do you actually measure a breakthrough or a new discovery? How do you put a score on a revolutionary insight? It feels impossible to boil something so complex down to just a score.
And yet, for decades, that's exactly what the academic world has tried to do. A researcher's work is so often judged not by what it says, but by where it's published, specifically by the ranking of that journal. And that ranking, it all comes down to one single number.
All right, so here's how we're going to break this all down. First, we're going to tackle the myth of the top journal. Then we'll get into the secret origin of the number that started this whole thing. We're going to see why averages can be so misleading, explore the really high stakes of relying on this system, and then finally look at how we can start measuring what actually matters.
Okay, let's dive into the core belief in academia. The thinking goes something like this. The better the journal, the better the research that's published in it. Simple, right?
And this, right here, is the academic prestige economy in a nutshell. Getting your work into a so-called high-impact journal is the absolute gold standard. It influences who gets hired, who gets funding, who gets promoted. It's publish or perish, but with a really, really narrow definition of what it means to succeed. And listen, this isn't just some vague cultural pressure. A survey of universities in the US and Canada found that a staggering 87% of them use a specific journal metric, the journal impact factor, when they're making decisions about promotion and tenure. It's just one number, but it is deeply baked into the system.
So where on earth did this all-powerful number even come from? You'd think it was designed by scientists to be a rigorous way to assess research, right? Well, the answer is a hard no. Its origin story is way more mundane and honestly pretty surprising.
The journey of the Journal Impact Factor, or JIF, is just wild. It was actually created back in 1972 for a very practical reason: to help librarians figure out which journals they should subscribe to. That's it. It was never ever meant to evaluate individual scientists. But then in the 90s, business schools started using it as a shortcut to measure research quality, and it just exploded from there. A simple library tool accidentally became a global yardstick for scientific careers.
So what is this thing exactly? The JIF is basically a journal's average score. You take all the citations its articles received in 1 year for papers from the previous 2 years, and you divide that by the number of articles it published. The key thing to remember here? It's a group statistic. It tells you something about the journal's average, not about any single article inside it.
And that right there, that brings us to the absolute core of the problem. Because using a group average to judge an individual, well, that's a classic statistical mistake. And it actually has a name.
It's called the ecological fallacy. And the analogy here is perfect. It's like saying that because a school has high average test scores, every single student in that school must be a genius. We all know that's absurd, right? Of course it is. Yet, that is the exact same logical error we make when we use a journal's average score to judge an individual piece of research. And the reason this fallacy is so destructive here is because of how citations actually work in the real world. You might think they'd follow a nice, neat bell curve, where most articles get a number of citations that's pretty close to the average. But the reality? It's not like that at all. The distribution is incredibly lopsided. Let's just take the Academy of Management Journal as an example. Its JIF was a very impressive 10.19, so you'd think, okay, the typical article gets about 10 citations. But look at the actual data. It's completely skewed. Most of the articles get very few citations, while a tiny handful of superstar papers get hundreds and hundreds, which drags that average way, way up.
And here's the punchline. For that exact same journal, 63% of its articles, that's nearly 2/3 of them, received fewer citations than the journal's fancy average score. That average isn't just a little off, it's a terrible representation of a typical paper in that journal. And this isn't some weird one-off case. This pattern is the norm. It holds true across basically all top academic journals. The JIF isn't measuring the typical article's impact at all. It's a number that's being massively distorted by just a few runaway hits.
So, okay. It's a statistical error. Big deal, right? Well, yeah, it is a huge deal. The consequences of this are profound, and they affect not just individual careers, but the entire direction of science itself.
The fallout from this is just immense. This system creates a publish or perish culture that can push researchers to avoid risky or really innovative topics and instead chase after safer publications that are more likely to get into a top journal.
In the worst cases, it can even motivate sketchy research practices. And at the end of the day, it distorts the most important decisions in science: who gets hired, who gets promoted, and who gets funding.
This quote from researcher Dennis Torish just cuts right to the heart of it. When the system rewards the place you publish more than the substance of your work, the goal itself can shift from advancing human knowledge to just, well, advancing your career.
Okay, so the system is deeply flawed. But here's the good news. There are much better ways to do this, and the conversation is finally shifting towards a more thoughtful, more accurate way of looking at research.
The path forward really has 3 key steps. First, and this is the big one, we have to stop making this category error. We have to acknowledge the GIF describes a journal, not the articles inside it. Second, we need to use the right tools for the job, metrics that actually evaluate articles and researchers on their own terms. And third, and this is for the institutions, we have to rethink the entire reward system to value all the different kinds of scientific impact.
So what are some of these better tools? Well, they include things like the H-index, which measures a researcher's consistent impact over time, or altmetrics, which are really cool. They track influence beyond academia in things like policy documents, news reports, and social media. The crucial difference here? All of these tools measure impact at the correct level, the individual researcher or the article itself.
And you should know, this isn't just a theoretical debate happening in some ivory tower. There's a global movement called DORA, which stands for the Declaration on Research Assessment, that's actively pushing for this change. Thousands of institutions and funders have already signed on, committing to end the misuse of the journal impact factor in career decisions. The change is already happening.
You know, what we choose to measure always shapes what we do. So the question we're left with is actually a really hopeful one. If we start using better, more accurate, more meaningful ways to measure scientific impact, can we unlock a more creative, more daring, and a more genuinely impactful future for science? That's really the whole ballgame. Thanks for joining us.